Hi everyone. I'm going to show you how to balance chemical equations, but before I do that, I just want to give you the rationale as to why we have to balance even in the first place. So using Lego pieces, this is basically the chemical reaction. We have magnesium, we have an oxygen molecule, which is made up of two blue oxygen atoms that were chemically bonded together, okay? And then it ended up making a magnesium oxide molecule here. Now, when we start, this isn't here yet, right? So what happens is, in a chemical reaction, the reactants have to actually come in contact with each other. So they're going to come in contact, a chemical bond will be broken, and I will make a magnesium oxide. Now, there's a problem here. What about this one? Where did this one go? It's not accounted for over here. Now remember, you cannot create or destroy atoms. And in this case, if this is all we end up with is magnesium oxide, right? There's no mention of an oxygen atom. So what I would have to do is I would have to actually take this away. But that's illegal. You can't do that in chemistry and in science. You cannot destroy an atom. So because of that, we have to do something called balance a chemical equation. Now, in order to do this, a student of mine who was very, very smart started doing this, and then I thought this was a great idea, is they started putting boxes in front, okay? Now, I'm going to tell you this. In this case, all the chemical formulas were given to you. If you have to come up with the chemical formula on your own, don't worry about balancing it yet. What you need to do is get the chemical formula correct. Once you get it correct by doing symbol, symbol, valence, valence, and then crisscrossing it, once you have all the formulas correct, then you go and balance it. If you get the formula wrong, you will get the balancing incorrect automatically, okay? So this is where nomenclature is going to come into play a little bit. Now, once I do that, I am only going to put a coefficient or a number in these boxes. I'm not going to mess with the subscripts. The subscripts are there because of valences and how it basically forms a stable compound, okay? The other thing I'm going to do, and this is something I find useful in doing this, is I'm going to set up what I call an inventory. So I basically am going to divide my reactant side and my product side. And on both sides, you should have the same atoms. Okay, so what we're doing is we're counting atoms. We're not counting molecules. If there's a magnesium here and there's not a magnesium on this side, then you know automatically that there's a mistake because, again, you cannot destroy atoms. Okay, so what I'm going to do is I'm going to take an inventory. So on the reactant side, I have one magnesium and I have two oxygen. On the product side, I have one magnesium and one oxygen. And we knew that when we looked at the Lego pieces. Remember that we had two blue Lego pieces over here, and on this side we only had one. Now that's illegal. So now what we have to do is we have to what's called balance the chemical reaction. So what I'm trying to do is I'm going to try and put numbers in here to balance my inventory. So if I put a 2 there, I am going to change everything after it by multiplying it by 2. So instead of one magnesium, I'm now going to have 2. And instead of one oxygen, I'm going to have 2. Now the cool thing about doing that is my oxygens are now balanced. My magnesiums aren't anymore. But if I put a 2 there, that now gives me 2 magnesiums. And now everything is balanced. Now, when we go with Lego pieces, look what would happen. If I had 2 magnesiums and one oxygen molecule, right? And then they go through a chemical reaction, what's going to happen is they're all going to get together. The oxygens are going to break apart and form 2 magnesium oxides. And all the Lego pieces are accounted for. So that's basically why we balance, is to make sure that the number of atoms we start with are the exact same number of atoms that we finish with. Okay? So here's another example. I'm not going to use Lego pieces for that one. But once again, I tend to put little squares in front You don't have to, but remember, this student was in the 90s and did it, and she did it basically to force herself to not change these subscripts. So I figure if she does it, we can all do it. Line to separate the reactants and products. Okay, I have sodium, hydrogen, and oxygen atoms on this side, and I try and keep them, they may not appear in the same order, but I want to write them down in the same order. It makes it a lot easier to compare. Instead of crisscrossing trying to compare, you're just looking directly across. So in this one, I have 1 sodium, I have 2 hydrogens, and 1 oxygen. On this side, I have 1 sodium. Now, be careful here. What I tend to do is I say there's 1 and then there's 2 hydrogens. I don't like putting 3 there, and I'll show you why in a minute. In oxygens, there's just 1. Okay? Now, everything seems balanced here except for the hydrogens. Now, you're going to find that if you like logical problems, you're going to love balancing. If you don't like logical things like Sudoku puzzles and stuff like that, then you're going to find balancing to be a pain. The other thing about balancing is the only way you're going to get good at this is by practice. The more you practice, the better you're going to be at balancing. Okay? So the best way to do this is I have an even odd number here, and that's a problem. I don't want to do that. So what I'm going to do is I am going to try and even this up. So instead of making this an odd number, I'm going to try and make the hydrogens an even number. So I'm going to make this a 2. When I do that, I now have 2 sodiums. I'm going to have 2 oxygens. And instead of 1 hydrogen here, I have 2. So I'm only going to change this one to a 2. So that's kind of why I separate it. Okay? Now, by doing that, I've messed with the sodiums. So if I make that a 2, that'll change that. So my sodiums are now balanced. I have 4 hydrogens here, 2 here. So what I can do is if I make this a 2, I now have 4 hydrogens, which is what I have over here. So that's balanced. I'm going to have 2 oxygens, and that's balanced. And that's how that one works. Now, what you're going to find is on balancing, I'm going to have what I classify as easy ones, medium, and difficult ones. Every one of you in the class has to be able to handle the easy ones. If you don't, then you just don't know what you're doing in balancing. Medium ones, you should get them most of the time. You may not get them all the time, but most of the time you should get. And then the difficult ones, well, depending on your average and how well you understand this, some of you may never be able to get the difficult ones. And that's okay. That's why they're difficult. All right, let's go through another couple of examples. So on this one here, again, I tend to put these boxes in here. I'm going to do my inventory. So I have potassium, chlorine, and oxygen. Potassium, chlorine, and oxygen. Now notice how I'm setting this up, right? I didn't do the inventories. I'm just trying to make sure that they're all the same on both sides. And now I'm doing my inventory. I have 1 potassium, 1 chlorine, 3 oxygens, 1 potassium, 1 chlorine, and 2 oxygens. You can do this part in pen, but after this, trust me, do everything in pencil. You're going to be using a lot of your eraser, or you're going to be using a lot of whiteout if you're using pen. So on this one here, there's a slight trick, and this is called a 3-2 combination. If you have a 3-2 combination, the only thing I can get that's common between them is if I multiply this by 2 to get 6, multiply this by 3 to get 6. So that's kind of what I'm going to do on this one. So I'm going to put a 2 there, which gives you 2 potassiums. It's going to give me 2 chlorines and 6 oxygens. Now, when I'm coming up with these, I am not simply multiplying these by 2. I am looking back up top here, okay, and then redoing my inventory. One reason why I suggest to do that is if you make a mistake down here, hopefully you will catch it when you go back up here and you're starting to redo your inventory from up there. Okay, I have 2 potassiums, 1 potassium here. So if I make this a 2, I have 2 potassiums, 2 chlorines. So these are balanced, these are balanced. And then this is the 3-2 combo, where if I go 3 there, that's going to give me 6. And then this one's balanced as well. Okay? Now, if you think you're getting this, you can clearly pause the video, try it yourself, and then play it afterwards just to make sure that you're getting them correctly. So these are all nice. They're set up for you, and you don't have to worry about nomenclature because you have the chemical formula. So again, I have carbon, hydrogen, oxygen, carbon. Now I'm going to write hydrogen next, even though I see oxygen here. Okay, hydrogen and then oxygen. So on this side I have 3 hydrogens, 8 hydrogens, sorry, 3 carbons, 8 hydrogens, and 2 oxygens. See, I got 1, I have 2 hydrogens, and here I have 2 plus 1. All right. Now, if you look this up other places, if you saw it in a textbook, they tell you to save hydrogen and oxygen for the end and stuff like that. There's no real right or wrong place to start. Just sometimes there's easier places to start at. So I'm going to start with carbon here. I'm going to try and balance that out. So if I make this a 3, I have 3 carbons, and I'm going to have 6 oxygens here. This is where I like separating them again. So that's good. Let's go with our hydrogens next. So if I put a 4 there, that's going to give me 8 hydrogens. And instead of 1 oxygen, 4 times 1 is going to give me 4. Now that locks me in there at 10. So my carbons are balanced, hydrogens are balanced. I have 10 and 2, so that makes it pretty easy. If I make that a 5, 5 times 2 is 10. And then that one's balanced. Okay, so that's how you would do that one. Let's go through this example. So in this example, again, it just takes a second to draw these boxes in there. Inventory, I got nitrogen, hydrogen, oxygen, nitrogen, hydrogen, oxygen, 1 nitrogen, 3 hydrogens, 2 oxygens. I have 1 nitrogen, 2 hydrogens, and 1 and another 1 on the water. So there's my combination on that one. So where do we start here? I have a 3-2 combo. So what you might want to do, this is going to be wrong, but you might want to think, oh, I'm going to make that a 2, right? To try and get 6 oxygen. So if you do that, I would end up with 2 and 6. So I need to make that a 2. And that would be a 2. I need this to be a 3, right? To make 6. And then this is 3. Now, everything looks good, and then I have 2 and 5. I'm never going to get the 2 to be 5. So whenever you end up with something like that, everything else is balanced except for the final one. You have an odd-even combination. The kind of trick on this one is you double the numbers. So instead of this being a 2, I'm going to make this a 4. When I do that, this is where pencil comes in handy. I'm going to have 4 nitrogens. I'm actually going to have 12 hydrogens, 4 times 3. I'm going to now have to double this. So that's going to be 4. This is now going to be 4. I'm going to double this to make it 6. That's 12. And there is 6 oxygens here. That's a total now. This is locked in at 10. So I think you can see that if I make this a 5, that makes that a 10. So this would be classified as a medium one, creeping up on difficult. Okay? Another hint on this, when you are going through this, please don't try and do all these ones on your own. FaceTime, Snapchat, whatever you need to do, call, text other people. If you get stuck, ask other people for help. Now, when you do that, and someone asks you for help, I don't want you giving them all of the coefficients. If you do that, you're not really helping them at all. What I would do is I would just, if someone called and asked me, hey, I can't get this one, all I would do is say, okay, the first number is a 4. So what you've done is you've given them a hint, you've made it a little easier, but they still have to know how to balance. If they still have trouble, they can come back, text you again, and then you can say the second number is a 5. And then at that point, you've pretty much knocked it into the easy realm, and then they should be able to handle that. Okay? So hopefully that helps. Take care.